Hello, everybody. Welcome to our population practice review video. This is where I'm going to practice what we did the other day, but kind of give you a chance to watch me do it and kind of slow it down a little bit. So some of the things we may have to do in this unit is take a decimal point and turn it into a percentage. So if you do a crazy division problem and you get a decimal, which we will be doing, in order to turn it into a percent, you simply multiply whatever you get by 100. So 0.4 would be 40%. 0.02 would be 2%. And this is where kids have a little bit of trouble with the decimal and the zero before a number. 0.636 is going to be 63.6%. And finally, two zeros, that's annoying. This is going to be 0.12%. In essence, all I did was move the decimal 2 places. And that's what's nice about multiplying by 100. I can also go the other way. And I can also go from a percentage back to a decimal. And again, we're going to divide this time by 100. And again, we're going to move 2 places. Now, because we're dividing, we're going 2 places the other way. So 56% is going to become 0.56, 2.79, 0.0279. Got a 0 here, that's annoying. 0.0023. Oh, scratch that, one more 0. 0023. And then this one here is 0.0000945. So instead of moving 2 places to the right, we're going to move 2 places to the left. And that's how we turn things from a percentage into a decimal. Now let's do a little bit of math and let's look at how we can take these numbers, get a decimal point out of them, then turn it into a percentage. So in this case, I have 93 people out of a total of 643 that can whistle. So you're going to take whatever you have over your total people. In this case, it's 93 over 643. And that's going to come out to a decimal value of 0.14463. Well, I want to turn that into a percentage. So again, this time I'm going to multiply by 100, aka move it over 2 places. That's going to make it 14.463. If I want to round it to the tenths, I could simply round it to 14.5. The questions I give you on your actual test or anything that counts will tell you what to round it to. So don't feel like you have to remember that. Let's try another one. Now the numbers are larger, but it doesn't matter. It's all about a ratio. So I'm taking my 93,879 people that can do a flip over my population of over 2 million, almost close to 3 million people. And when I do this crazy math, I'm going to get 0.033. And I want to turn that into a percentage, move it over 2 places, 3.35%. Once again, let's round it to the tenths, 3.4%. So that's how you can take some crazy math value, get a decimal point, and then turn it into a percentage. That again is going to come back around, going both ways when we do these problems. What if I want to make it a crude value? Now, a crude value is basically how many people per 1,000. And this is what you're going to do when you talk about large numbers, when you're talking about large populations. So now we have a couple of scenarios here. So let's do the math again. So this time I have 606,000 people and 899 out of a grand total of 2,440,643 people can do a flip. That is going to give me a decimal value of 0.2486. Now we know how to turn that into a decimal point. That's pretty easy. We're just going to move it over 2 places or multiply it by 100. And if we do that, we're going to get 24.86. And of course, I could round that to 24.9 if I wanted to. That's this nice simple round. And then crude value, now in this case, I'm going to then multiply that again by 10. And you're like, well, why would you do that? Well, that means that for every 1,000 people, 249 of them are going to be able to do whatever it is. Now, you say 249 out of 1,000 is a lot, but 600 and change thousand out of 2 million, that's a high percentage. What the instructions say is I can go from a decimal to the crude by multiplying by 1,000. Well, if I go from my decimal to my crude, if I jump over that spot, 100 times 10 would be the same thing as saying multiplying it by 1,000. Now, the good news is any real question is not going to be this involved nor this annoying. But I wanted you to see how the process works, and that's why we did this. So you can see here, I can take the decimal, multiply it by 1,000, which I did, or I can take my percent and multiply it by 10. So I could do all of that, and that would work just fine. Well, what if we're going the other way? We got to go back. We got to go from a crude birth rate back to a percentage. How the heck are we going to do that? Well, we're going to divide by 10 this time. So 19 divided by 10 is 1.9. Well, how the heck am I going to get it to a decimal? Well, I'm going to then divide it again by 100. For a grand total going backwards would be the same as dividing it by 1,000. So in this case, 0.0019. And you can see that going in either direction between the decimal and the crude or the crude and the decimal will either be multiplying or dividing by 1,000. Well, what if they give you some values and now you have to figure out all this stuff, including doubling time? No problem. We know to find what is called the crude growth rate, we're going to take the crude birth rate minus the crude death rate. And in this case, I was nice, and I gave you the birth rate and death rate. So I gave you the 45. So a lot of people were born per 1,000, and only a few people died per 1,000. That means this population's growing pretty quick. My CGR is 31. So now, how am I going to take that 31 and turn it into a percentage and figure out this whole doubling time? No problem. So I know my crude growth rate is 31 per 1,000. So we got that. Now to go to a percentage, again, this time we divide it by 10. 3.1% of the population is growing. Now that's a lot. So I want to determine how long it's going to take for my population to double. It's called doubling time. So you take this magic number of 70 and divide it by the percent increase. So in this case, the 70 is a given value. The 3.1 I figured out. And that is going to give me a doubling time of 22.58 years. That is pretty quick. So if we had a population growth like that in this world, we'd be in trouble. But we don't, which is good. All right. Now, what if this time I gave you some values, but I left some out? So we know, once again, crude growth rate equals crude birth rate minus crude death rate. And this time they gave us the birth rate, which was 16. They gave us the growth rate, which was 6. Now we have to figure out the death rate, and, a little easy math. We learned that in the old days, 10. Now, when I'm figuring out the doubling time, I need both of these values to figure out the growth rate. Of course, I gave you this question to trick you a little bit. So the key there is the 6. Well, we got to turn it into a percentage. So how are we going to do that? Again, divide by 10. 0.6%. Now, 0.6% is way less than last question. So this population is going to take way more time to double. So let's see. 70 divided by 0.6%. And we put that in our calculator, and we are going to get, of course, oh, there it is. We are going to get 116.66 years. As you can see, with a smaller rate, it will take more time. All right. And let's see what we got. Well, now I have to figure out what my population is going to be next year. And I'm saying to myself, how am I going to do that? Well, I have to know some things. I have to know the current population, which in this case is 5 million and change, close to 6 million. I have a crude growth rate, which I know how to turn into a percent, which is nice. I know how to turn it into a decimal. And I have this little weird thing right here, but we'll get to that in a second. That's going to allow us to find our new population. So let's see what I know. I know that I have a crude growth rate of 32 people per 1,000. So to divide that by 10, my percent increase is going to be 3.2%. As a decimal, 0.0032. So again, this is what we've been doing, on and on. Now, why do I add a 1 to that? Well, I'm going to do 1.0032 because that is taking into account the population and then adding the percent increase or this amount of increase. So in this case, I know that it is 5,876,221. I'm going to multiply that by 1.0032, and that is going to give me a new population of 6,064,260.7. But I'm going to round up because I can't have 0.7 in person, so we're going to round up. And of course, the bell's going to ring in 5 seconds, so let's let that go. 6,064,261. Because again, we cannot have 0.7 of a person. We're going to just round up. All right. Now this time, the percentage increase is smaller. Starting out with 6 million and change people, let's do every single thing the same way we just did it. To go from a percent to a decimal, 0.0011, 1.0011. I take my population of 6,098,221 and I multiply it by 1.0011. And that is going to give me a new population of 6,104,929.04. Once again, round up, because we can't have 0.04 people. 930. So that is my new population. What if I want to do that in 5 years? Well, then that's, again, you're not going to have to do this in anything marked by me, which is great. But here's the formula. Decimal, once again, is 0.0011. So 1.0011. That doesn't change. Now we have our fun math problem, which is our original population of 6,098,221 people. Then we're going to multiply it by this. 1.011. We're going to raise it to the 5th power because that is the amount of years compounded on itself. So our grand total, our new population, after 5 years, is going to be 6,131,835.085. Once again, we cannot have 0.085 people. 6,131,836 people in our population. And let's put it all together. If we put it all together, now this is about as annoying as it's ever going to get. In this case, I'm telling you how many people we have 45,000 and change. Not too many. Some people were born. Check. Some people moved in. Check. Some people died. Check. Some people moved out. Check. So if you get your original amount of new people, you take your births, which was 2135, plus your immigrations, which was 245 people. Then you're going to subtract the amount of people that died, which was 1149, and the amount of people that left, which is another 199, which gives you a grand total of 1,032 new people for a new population of 46,813 people. All right, that's great. That's like right now. That's what's happening now. But I want to know how to figure out these percentage increases and growths. So I'm going to take my amount of new people, which is 1,032, over my original population, which is 45,781. And that's going to give me a decimal increase of 0.0225. All right. Turn it into percentage. We know how to do that. We multiply by 100, 2.25. And then, of course, if I want to turn it into a growth rate, it becomes 22.5. I'm sorry, a crude growth rate. Now I have every single thing I need in order to get my answer. And here's what I do. I want to know how long it's going to take my population to double. So I do this. Take the number 70 and I divide it by the population growth rate. So 70 divided by 2.25, which is what I figured out from last time. And this population is going to take 31.11 years to double. So that is everything. So hopefully that helps.